This section examines the operation of the drum brake. Drum brakes were once common on all wheels of light vehicles. But on modern designs, they are usually found on just the rear wheels, in disc drum combinations. The drum brake has two brake shoes with a friction material called a lining attached. These shoes expand against the inside surface of a brake drum and slow the wheel down. The harder the linings are forced against the brake drum, the higher the braking force that is applied. They can be expanded mechanically or hydraulically. The main advantage claimed for drum brakes is that the shoe mountings can be designed to assist their own operation. This is called self-energizing. Less hydraulic pressure is then needed to stop the vehicle, which is why many older drum-braked vehicles didn't use a brake booster. The main disadvantage of drum brakes is that the friction area is almost entirely covered by lining, so most heat must be conducted through the drum to reach the outside air to cool. With hard use, this can cause overheating and eventually brake fade. Brake fade is the gradual loss of brake stopping power during prolonged or strenuous use. Very high temperatures occur at the brake drum, and that causes a deterioration in the frictional value of the lining or pad material. It's common in drum brakes. Another problem with drum brakes is that it is difficult to get water out of the drum. If a vehicle is driven through water, it takes longer to get the brakes working effectively. 3 brake designs are in general use: single leading shoe, twin leading shoe, and duo servo. Each one uses the wedging or self-energizing action of the brake shoe to assist the lining to grip the rotating drum when the brakes are applied. The twin leading shoe has an actuator for each brake shoe. The actuator can be mechanical. However, a hydraulic actuator is popular on light vehicles. The hydraulic actuator is called the wheel cylinder. This arrangement has 2 wheel cylinders with 1 piston in each cylinder. When the brakes are applied, hydraulic pressure forces each piston to move outwards, pushing on one end of the brake shoe. The direction of rotation of the drum produces a wedging action on both brake shoes, so they are both called leading shoes. This system was once popular on front wheels because it is very efficient in the forward direction. This is due to the self-energizing or self-wedging action of the shoes as the drum rotates. Its main disadvantage is that it is only about 30% as efficient in reverse, so it is usually combined with a single leading shoe arrangement on the rear to provide a balanced system. The single leading shoe system uses a single wheel cylinder with 2 pistons. When the brakes are applied, both shoes press against the brake drum. One shoe is called leading shoe, the other is called trailing. The leading shoe tends to be self-energized, while the trailing shoe tends to be forced off the drum. This arrangement is common on rear wheels as they work equally well in forward and reverse, so it makes an effective handbrake. They can also have a self-adjusting mechanism. The duo servo design also uses 1 wheel cylinder with 2 pistons. It is a high-energy brake, that is, it exerts large self-energizing forces. The lower ends of the shoes are linked but aren't firmly anchored to the backing plate. This lets the complete shoe assembly float within limits. When the brakes are applied, both shoes are carried around by the drum until the secondary shoe contacts the anchor pin. The self-energizing force of the primary shoe and its wheel cylinder application force is now transferred to the secondary shoe through the lower linkage. Force is then being applied to the secondary shoe from both ends, the wheel cylinder at the top and the linkage from the primary shoe at the bottom. The primary shoe has the shorter lining and is always fitted ahead of the wheel cylinder in terms of drum rotation. It's most important that the shoes are fitted correctly, since it's the secondary shoe that does most of the work. The linings may also have different frictional values. The colours of the retraction springs indicate different spring strengths. This design is common on rear wheels and it works well in both directions. Drum brake systems need to be adjusted to allow for wear of the lining. If they are not adjusted, pedal travel will be too long to be safe.